All right, let's dive right in. Today, we're getting into the mind of an AI to tackle a pretty deep question. When an AI seems to be reasoning, is it actually thinking, or is it just a master of linguistic tricks? Well, a recent study has uncovered some absolutely fascinating clues, so let's get into it.
Okay, so here's the central mystery. We've all seen AI models solve incredibly complex math problems when you ask them in English. But here's the kicker. Is that intelligence real? Is it universal? If you ask it the exact same question but in a language like Swahili that it wasn't really trained on, does the genius hold up? Or does the whole illusion just fall apart?
And this gets us to the core of the problem with these big AI models, right? Are they developing a true, abstract understanding of logic itself, or are they just getting ridiculously good at recognizing and manipulating patterns that they've seen over and over again in the English language?
What's so interesting here is how different that is from our own brains. For us humans, cognitive neuroscience shows that our core ability to reason is a totally separate process from the language we use to talk about it. So the billion-dollar question for AI is the same true for them? Or is their ability to think forever chained to their training language?
And you know, this quote from the researchers who did this study, it just nails the whole issue. Are we actually building a real thinking machine, one with universal intelligence, or have we just built a very, very convincing but ultimately limited English-speaking calculator?
So how do you even start to solve a mystery like this? Well, the researchers basically put on their detective hats and started gathering clues. They kicked off a huge observational study, and let's take a look at the evidence they found.
First up, they decided to just test it. They grabbed 13 popular AI models and gave them a massive math test. But they didn't just ask the questions in English. Nope, they translated the exact same problems into 10 other languages, everything from Spanish and Russian all the way to Bengali and Swahili, just to see what would happen. And what came back was just chaos. Pure chaos. As you can see here, a model's ability to transfer its reasoning skills was completely all over the map. Some did great, others not so much. Some actually got worse. There was no clear pattern at all, which, only made the mystery deeper.
And this is where things get really weird. They found this clue that it doesn't seem to make sense at first. The models that were the absolute best at math and English, they were often the worst at doing it in other languages. They were overfitting, learning these little English-specific shortcuts instead of the actual universal logic.
So, faced with all this weird, contradictory evidence, the researchers came up with a really elegant, really powerful new idea, the parallel solution.
It all came down to this one question. What if? What if you could force the AI to look past the words on the surface and find that deeper, universal logic underneath? The key was to show it that the same concept exists no matter what language you use to describe it. They called their strategy Just Go Parallel. And honestly, it's so simple, it's beautiful. You take a math problem in English, you translate it perfectly into a bunch of other languages, and then you train the AI on all of them at the same time. This forces it to connect the dots, to see the same core idea through different linguistic lenses.
And here's the really important part. The goal wasn't just to make a better translator. The goal was to force the model to build a kind of abstract reasoning engine inside its own virtual brain, something language-agnostic, something a little more human.
And the results of this experiment? Wow, they were incredible. They didn't just see a little improvement, no. They discovered 3 fundamental, predictable laws that seem to govern how AI learns to think more broadly.
First up, they found something so huge, so dramatic, they had to give it a name, the first parallel leap. And this was a total game changer.
I mean, just look at this chart. The second they went from training only on English to English plus just one other language, bam! The AI's ability to generalize just exploded. It wasn't a small step, it was a giant leap in performance.
Okay, so that was discovery number 2. After that massive initial jump, they noticed that the improvement wasn't random at all. As they added more and more languages, the gains started following this really smooth, predictable curve, a clear mathematical pattern.
They called it the parallel scaling law. It means the model's performance scales in a predictable way. It's a power law. So think of it like this. That first new language you add gives you this massive boost. The next few give you a big boost, but a little less. And as you keep adding more, you still get better, but the gains get smaller. It's basically the law of diminishing returns, but it gives us a predictable path to building a smarter AI.
And this beautiful, predictable curve, it led them to the final piece of the puzzle, the smoking gun that finally solved the mystery of that English-only genius.
So they used this new law, this curve, to predict how a model trained only on English should perform if it were truly reasoning. And guess what? The actual performance was way, way lower. This difference, what they call the Monolingual Generalization Gap, that was the proof. It showed the English-only models weren't really reasoning. They were just using shortcuts, little tricks specific to the English language.
Okay, so we've solved the mystery, but what does this all actually mean? Why does this matter for the future of AI, beyond a research lab?
Oh, this is huge. Seriously, it means we can now build AI that's more fair, more equitable for the billions of people who don't have English as a first language. Imagine a medical AI that works just as perfectly in Swahili as it does in English. It means we can build models that are less biased by the weird quirks of just one language. And maybe most importantly, it's a huge step toward an AI with the more genuine, abstract intelligence, something that starts to look a lot more like how we think.
So what this all boils down to is that we now have a roadmap. We have a way to understand and, more importantly, to fix a really fundamental flaw in today's AI. We now know that by default, it doesn't think like we do, but we also know how to help it get there.
And that leaves us with one final, really big question to chew on. If we can teach an AI to think beyond the limits of a single language, what other cognitive barriers can we help it break through next? By pushing AI to think more universally, we're not just making a better tool, we're literally pushing the boundaries of what intelligence itself can even be. Now that's a fascinating thought.